Hello. So this is the second part of my project. I wanted to talk about subtraction. Uh, so what we have here is we have a three-digit whole number minus another three-digit whole number. Our first number is 382, second number 195, and I've went ahead and already drawn a graph out to illustrate that when we subtract, we're going to be taking um, like terms and either combining them and breaking them down or borrowing from one place value to the other. So, for example, 2 minus 5, I know I can't do that, otherwise, I would get a negative number. But what I can do is I can borrow from my friend here in the tens spot. I'll cross that out, make it a 7, and I can make this 12. I took one away from my tens and gave it to my ones. Um, so now I have 12 minus 5. It's going to be 7. Now I can go over to my next place value, the tens spot, and just go work straight down with the like terms. 7 minus 9, I can't do that. If I have 7, I don't even have the 9, so I can't take it away. So again, I have to borrow from my friend here on the other side in the hundreds place value. So I take 1 away to give 1 here. Now I have 17 minus 9, which is 8. And I just come to my hundreds. I have 2 minus 1, simple, easy, 1. So you could see we kept the ones spot all together, dropped it down, tens all together, dropped it down, and same with the hundreds. Okay, now in order to do our subtraction, but with fractions, we are going to have to keep like terms together. So our denominators, here the numbers on the bottom, we'll have to keep them together. And our numerators, we have to keep them together. And we'll be subtracting the numerator from the numerator and denominator from the denominator. But in order to do that, I have to make sure, as we talked about in the addition, I have to make sure that my bottom number is the same on both sides of this equation and over here. So in order to do that, I can look at all the factors of 4 to see if any of them get to 16, which I have done right here. We have 4, 8, 12, and 16. So I can see, oh, something in 4 plus some, or 4 times something makes 16. So I can come over 1, 2, 3, 4. All right, so 4 times 4 would make that 16. So I can have equal denominators, both with 16, so that I can do our bounce method and bounce it over. So we'll do 4 and 4, because we know if we do something to the denominator, we have to do it to the numerator. So 4 times 4 is 16. 3 times 4, well, I did it up here, 4, 8, 12. That's the third one. So 12. 12 sixteenths minus 7 sixteenths. We didn't have to change 7 sixteenths because it was already a 16. The bottom numbers were exactly the same, so we didn't have to do anything with that in means of changing it. So now that we have that, we have our 16. We bounce it over. Oh, it's also a 16. Bounce it to the next one. Well, then if these are the same, that means that's going to be also the same. Now that we've made it the same, 16. And then we can come and just do 12 minus 7. Simple subtraction problem. We're going to get 5 sixteenths, and that is our answer. So sticking with the theme of adding or combining like terms together, we're going to look at subtracting mixed numbers from mixed numbers with obviously different denominators. So what I've went ahead and already done is illustrated and highlighted our liked terms. So I have a 5 that's a whole number, and I also have a 4 that's a whole number. And if I look at how the problem is set up, I can kind of tell what my solution will look like. So if I have two whole numbers, I'm probably going to have um, a whole number here and some kind of fraction, because there's some kind of fraction in both of these on the back half of the solution. So in order to do this, what we can do is just um, simply combine and subtract like terms. So the 5 and the 4, like I previously said, are whole numbers. So why don't we just subtract those from each other and get our whole number of 1. 5 minus 4, 1. Now, we can hold on to those, not really worry about that. Now that we've done that, that was the easy part. We can just kind of get rid of them and now work with our fractions. So we need to find a factor like we did in addition and in our previous problem. We have to make sure that both of the numbers in the denominator are the same, so that when we translate it and get our solution, both are all of the numbers are the same in the denominator. So we have to find a factor of 7 and 14. I did it kind of down here. I know that 7 times 2 is 14, times 7 times 3, 21, 7 times 4, 28. Well, I could see immediately that we have a common factor of 14 and 14. So what did I have to do to get to that 14? Well, I had to add 7 2 times, or multiply 7 times 2. So we come down here and we can make the 7 into a 14. So by just multiplying 2. So let's multiply 2 here and 2 here, because we know if we do something to the denominator, we also have to do it to the numerator. Just kind of cheat that. We're going to have now 14, and then 1 times 2, 2. Now, instead of our equation looking like 1 over, or 1/7 or 1 over 7, we can now do 2 over 14. Now that we have those common denominators, we can just bounce our denominator over, over, and over to make 14. Since that's the common denominator in both of the equations, our answer is going to also show that. So we have 14 there. And then we have, just to look at the top, 2 minus 1, or 1. And so it's going to give us 1 and 1/14. But we're not done yet. We have to make sure and remember that we have this 1 up here. So we just plug that back into the equation. It's going to give us 1 and 1/14, which looks similar to what we had here before of the 4 and the 5. Okay, so for subtracting decimals, it is going to be the exact same as if we were just subtracting whole numbers. However, instead of our number getting bigger to the left and growing into 1,000, or from 100 to 1,000 to 10,000, it's going to get smaller and grow the opposite direction. So we're going right instead of going left. And in order to show that, we will put a decimal after our whole number here to show that it's getting smaller and smaller as we go on. To do this, I kind of just want to do 1.42 minus decimal 75. We're going to set this up exactly as we've been setting it up with our columns together. We're going to line up our decimals, make sure that they're lined up so that we can easily keep our tens with our tens, our hundreds with our hundredths, and our ones with our ones, so that we don't get all out of line. If we line the decimals up, then we can make sure that all of our place values, whichever way we're going, remain consistent and together. So with our decimals lined up, all we have to do is drop this little guy down, and then we can just do our subtraction like we've been doing, just straight down in rows. So I can't take 2 from 5, so I have to borrow from a friend here. Goes to 3, that goes to 12, and that is going to go to 7. I can't take 3 away from 7, so I've got to take away here and go to 13 there, and that is going to give me 6, and then 0 minus 0, or nothing, is a 0. So by keeping our decimals together, it will keep our tenths, hundredths, and thousandths, and this could go on as long as you wanted it to, but it'll keep it in line so that we can subtract and keep our like numbers together.